So you might be asking yourself, how do forensic scientists use DNA to find criminals? 99.9% of your DNA is similar to that of any other person in the world. But that means that there is 0.1% of your DNA that is different. So that's 3 million base pairs of DNA that are different from anybody else in the entire world. And so that's what we use to figure out who committed the crime. So the first thing that they have to do at the crime scene is collect DNA either from hair or skin under a victim's fingernails or saliva or any other piece of themselves that a criminal might leave behind at a crime scene. In this case, we're looking at the saliva that was left on the Powerade bottle with the suspicious white powder. This is a very, very tiny bit of DNA that we can find in that saliva evidence. So to make more of the DNA, we make copies with polymerase chain reaction, or PCR. And so this can make lots of copies of the DNA in a very short period of time. And so now, after we have amplified the amount of DNA that we have, now we have enough to make fingerprints and compare the unknown evidence DNA with the known suspect DNA to see if any of those DNA fingerprints match up. So what on earth is a DNA fingerprint? So first thing we're doing with the DNA is using enzymes to cut it up into smaller pieces. These pieces are going to be different lengths for each person because these repeating nucleotide bases where the enzyme knows to cut are going to be at different places in different people's DNA because of that 0.1% difference, or that 1/10 of a percent different DNA. So once we have cut up all of the pieces of DNA with the restriction enzymes, we're going to put them into a gel. So the gel is like a matrix or like a maze. And it has little tiny holes in it, and the DNA can move through the little tiny holes at different speeds depending on what size it is. So if you have little teeny tiny pieces of DNA, it can find its way through the maze of the gel really quickly. If you have really big pieces of DNA, it's probably going to move really slowly because it's going to take a long time to find a path that it can all fit through. So it's going to get stuck up near the top where you put your DNA in, which is what we're going to compare all of the other DNA to. And then we have all of our suspect DNA. So we want to see which one of these strands of, or which one of these pieces of DNA ends up having the same or most similar fingerprint to the evidence DNA. And we're going to load our gel, starting with well 1 and working our way across and filling any empty wells with water. So take your DNA sample. Once you have all of your DNA loaded, you're going to apply a positive charge down at one end of the gel. Remember that DNA has a negative charge, and so opposites attract. And so those DNA pieces that are up here in these wells are going to be attracted to the positive charge, and they're going to move down the matrix. So our DNA has migrated down the gel, and our gel is ready to take out. And then we're going to look at it with a UV light, and that's going to help us see where the bands of DNA are. All right, so our gel might look something like this, where we have our evidence here, and we have all of our different DNA fingerprints of our different suspects. And we're just going to look and see which bands match up the best with the crime scene evidence.